In today's video, I will teach you how you can make I-type power supply with this UPS transformer. So you may know I am opening the APC 300 watt 500 VA UPS uninterruptible power supply, which I get this I-type transformer. Normally this transformer used as a step-up transformer. It takes 12 volt and stepping up into 220 volt. But you may know transformer are also step down and step up both. Now these transformers are only device which can forward bias and reverse bias. So normally this transformer is step up transformer. I use this transformer as a step down. So I do 220 volt over here and we get 12 volt or some other voltages with this output. So this is the input and this is the output. How you can identify which is output? In output side you can get every gauge wires, kit wires, and input side we can get very thin wires which carry very high voltage with low current, and this is a low voltage, a very high current output. So there are 4 wires. Wire 1 is common and 3 other parts are country wise. So it's worth 120, 160 and 200 and 220. So in order to properly find which wires which, we need a multimeter. You can use analog and digital both. I have this analog meter. Set it to the ohms range. I think you may not be see this time because it is very tiny. The multimeter set into 10 ohms. So it can measure less than 10 ohms. And we hold the multimeter, and I think little bit we need a zoom in the multimeter screen. Now I put this meter. I put this over here and then put over here, and now you can clearly see, maybe seeing the display on the multimeter when I probe it between brown to the white to the blue. Make sure multimeter stays on. That multimeter stays on. It shows first it says when I measure the white and blue wire, it says the resistance somewhere 3.5. When I measure between white to the black, it says resistance somewhere 4 ohm. And when I measure the black to the white, we get maximum 4 ohm resistance. Meaning we can use only which wires we get maximum resistance. So in these 4 wires we get maximum resistance between white and brown. So white and brown wire is the final input wire which I can supply 220 volt AC in, and we get 12 volt in over here. Take a multimeter side. So never plug directly your transformer into the AC mains because it will explode. In order to do that, we can use a series lamp. This is another what series bulb, but I don't have series board, so I made a little bit setup. Which setup is not a good setup. I not recommend you can make. That way you can not buy or little bit use a cost. Spend a cost to make your or buy your extension board, series extension board. Instead you can try which method I can show you right now. Which method? Alligator clips. If you have series, you can use series board. Series board, which is a AC series board, which I use under watt lamp, but I don't have series board, so I made a series circuit with alligator clips, and this circuit is totally bare. So accidentally, if anything is touching about, accidentally little bit touch in any point, we get electric short. So that's why very carefully we can do this. But if in your case you can use proper board, series board to do that. I put these needles into the socket. So I don't cut my socket right now, this jack. So I directly put the needles in and make sure the needles are not sharp to each other and it properly all the terminals. And now I can add alligator clips. Alligator clips. We need one more alligator clip, which is, I know it's one my alligator clip is missed. Diagram of transformer. There is contain a white wire, blue, black and brown. There's a yellow and orange is one side. There's a one standard and white and black is other standard. So it is two output and one input. Two output standard and one primary with multi taps. Now what we can do, we make sure these alligator clips are not shot back in the bulb. Or right now I plug this unit into a AC mains. Keep in mind you can always use series board and series circuit, not parallel, directly injected. I think we bring up close. Well, just bulbs will blink. Now check output voltage. This is output voltage AC, so we can check the AC voltage with help of these multimeter and set. We set AC volts, 10 volt AC. So my first meant can set this more than 50 volt AC, because it is no guarantee. There is a risk to over voltage come out that can kill your damage your multimeter. So that's why always set multimeter in higher range. In my case I can set max 50 volt. So I don't think output is no more than 50 volt. And this one way I can mold this is a standard output which is safe to touch, but I not meant because most of the time transformer will internally damage. It will give over voltage and not isolation, so that's why it sees somewhere 2 volt, meaning 20 volt. So right now it's set 50 volt range. Voltage is 20. So I set a 10 volts. It's that 8 volt. So now it is accurate. Now output voltage is 8 volt. I expect this 12 volt, but it is not 12 volt. Don't touch air. Very carefully. This is high current, low voltage output, and this is a low voltage with low current output. This time though there is AC volt, there is no positive negative, and it is C full 10 volts. So now what we can do, you may know, normally we can use a 12 volt. 12 volt is a common voltage we can use in every appliances like a battery charger and anything. So this transformer provides 8 volt. So we need to increase the voltage little bit. So that stage we can need to increase the resistance, meaning we can primary winding, instead we connected this time brown, we connected between white and black. So there the number of turns is decreasing and number of turns decreasing, meaning resistance decreasing, turn flow is more, which does little bit transformer more heating and produce more output. But this can reduce the transformer life little bit. But this thing, I tell you, this point you can always try in series with lamp. If you try without lamp, your transformer don't into sky. Now I change the wires. So basically we can white and first I had white and brown. Now change the connection. I will show you. This is a pin, and this pin I put somewhere 3.5, 4.5, I mean 4 ohms range winding. Now carefully plug in without this beer leads, and you can see bulb is tiny little below. If you are not connected this bulb and if still extra voltage to go to the transformer, and it can fly the transformer. So that's why I always connect series bulb. Now match your output voltage. This time I asked output voltage is not go too much, because when I decrease the turn, so as the voltage can run the bulb, it's never do transformer which has no output. So in order to make output little bit higher, we can remove the bulb and directly apply this voltage, because right now bulb is little bit low, which this little bit voltage go into a bulb. So when I remove the bulb and directly connect it to a transformer, this little bit voltage go instead of the bulb, it can go to a transformer, and then it drive the transformer a little bit harder, and then it can put output high voltage. It will, little bit more voltage. But this case, if normally do that, maybe transformer was burnt out. So in order to do that, we can first check also this one. Same 10 volts. This time you might be say this is a AC voltage. When you convert DC voltage, it's still little bit boost up by, because this is the average voltage. When you use a rectifier DC, it's come with a peak voltage. So peak voltage is always higher than average volt. Now you use rectifier to rectify and measure DC voltage by this voltmeter and check after there's no any difference or it's different. I am use